Okay, hello Cloud Gurus and welcome to this lecture. This is the final lecture in the VPC summary section of the course. Congratulations, you've done really well to get this far. Hopefully you have a deep understanding of VPCs now, and I would honestly go back and until you can build a VPC from memory with both public and private subnets, as well as with VPC endpoints and NAT gateways, until you can do it all by memory, I would not go and sit the exam. So long as you can do all this by memory, you will almost certainly pass the AWS Certified Solutions Architect Associate course. And also, if you can build out a VPC from memory, you're going to kill any job interview because you know exactly what to do. So let's start with VPC overviews and remember the following. So we thought of a VPC as a logical data center in AWS, and it consists of internet gateways or virtual private gateways, route tables, network access control lists, subnets, and security groups. Remember that one subnet always equals one availability zone, and remember that security groups are stateful. Network access control lists are stateless. So with our security group, all we need to do is go and open up a port, might be port 80 or port 22, and we didn't need to worry about our outbound traffic. It was all automatic. With network access control lists, we have to do both inbound and outbound. Also remember that you can't do transitive peering with VPCs. They need to be peered on a one-to-one basis, and you can peer between regions. So we then went on to build out our very first VPC, and when we created our VPC, it created a default route table, it created a default network access control list, and it created a default security group. It won't create any subnets, nor will it create a default internet gateway. And just remember that US East 1A in your AWS account can be a completely different availability zone to US East 1A in another AWS account. So the availability zones are randomized between AWS accounts. Remember that Amazon always reserves 5 IP addresses within your subnets, and remember that you can only have one internet gateway per VPC. You can't just go in and add multiple internet gateways to your VPC. You can only have one. Also remember that security groups cannot span VPCs. We then went on to learn about NAT instances. So when creating a NAT instance, you always disable the source and destination check on the instance. NAT instances must be in a public subnet, and there must be a route out of the private subnet to the NAT instance in order for this to work, and that the amount of traffic that a NAT instance can support depends on the instance size. And if you're bottlenecking, what you need to do is you need to go in and increase the size of the NAT instance. And you can create high availability using auto-scaling groups, multiple subnets in different availability zones, and then a script to automate failover. And NAT instances are always behind a security group. To be honest, you don't really want to use NAT instances in the real world. You pretty much always want to use a NAT gateway. And just remember how a NAT gateway works. Essentially, you've got your instance here. It has a route in its route table to the NAT gateway, and the NAT gateway has a route out to the internet. And so when your instance runs a yum update, it's going to the NAT gateway and then traversing out to the instance. And also note that your NAT gateway is not behind a security group. It exists on its own. In terms of NAT gateway, redundancy is available inside the availability zone. It's preferred by the enterprise. It starts at 5 gigabits per second, scales currently to 45 gigabits per second, probably scale even more in the future. You don't need to worry about patching NAT gateways, and they're not associated with any security groups, and it's automatically assigned a public IP address. And when you add your NAT gateway, just remember to update your route table so it has a route out to an internet, and you don't need to worry about disabling source destination checks on a NAT gateway. Also remember that if you have resources in multiple availability zones and they share the one NAT gateway, in the event that that NAT gateway availability zone goes down, resources in the other availability zones are going to lose internet access. So just by having a single NAT gateway, you do not have high availability. To create an availability zone independent architecture, what you have to do is create a NAT gateway in each availability zone and configure your routing to ensure that resources use the NAT gateway in the same availability zone in which they're in. Also, remember, moving on to network ACLs, so your VPC automatically comes with the default ACL, and by default, it allows all outbound and inbound traffic. You then can create custom network ACLs, and by default, when you do this, each custom network ACL denies all inbound and outbound traffic until you go in and add rules. And each subnet in your VPC must be associated with a network ACL, and if you don't explicitly associate a subnet with a network ACL, then the subnet is automatically associated with the default network ACL. And you can block IP addresses on specific ports using network ACLs. You can never do this using security groups. Remember that you can associate a network ACL with multiple subnets. However, a subnet can be associated with only one network ACL at a time. And when you associate a network ACL with a subnet, the previous association is removed. And remember that network ACLs contain a numbered list of rules, and these are evaluated in order, starting with the lowest number first. And you remember, if we had an allow and then a deny, the allow is going to trump the deny because it's evaluated first. So you must always, if you're going to deny something, you must put it in front of your allow rule. So network ACLs have separated inbound and outbound rules, and each rule can either allow or deny traffic. You can't do that with security groups. And network ACLs are stateless, so responses to allowed inbound traffic are subject to the rules for outbound traffic and vice versa. Moving on to ELBs and VPCs, just remember that you need a minimum of 2 public subnets to deploy an internet-facing load balancer. Moving on to VPC flow logs, just remember the following. You cannot enable flow logs for VPCs that appeared with your VPC unless the peer VPC is in your account. So you can't have flow logs across multiple AWS accounts. You can have them across multiple VPCs, but they have to be within the same account. You can now tag VPC flow logs, and after you've created a flow log, you cannot change its configuration. For example, you can't associate a different IAM role with the flow log. You could do that for EC2, but you can't do that with flow logs just yet. Remember that not all IP traffic is monitored with flow logs, so traffic generated by instances when they contact the Amazon DNS server is not going to be logged. If you use your own DNS server, however, then all traffic to that DNS server is going to be logged. Traffic generated by a Windows instance for Amazon Windows license activation is not going to be monitored. Traffic to and from 169.254.169.254 for your instance metadata and user data is not going to be monitored. And then DHCP traffic is not going to be monitored as well. And traffic to the reserved IP addresses for the default VPC router will not be monitored as well. Bastions, just remember what a bastion is and how it works. So we've got our instance in a private subnet. If it wants to connect out to the internet, it's going to do that using a NAT instance or NAT gateway. If, however, we want to SSH in or RDP into our instances in our private subnet, we do that via a bastion host, and sometimes these are called jump boxes as well. So just remember that a NAT gateway or NAT instance is used to provide internet traffic to EC2 instances in private subnets. A bastion is used to securely administer EC2 instances using SSH or RDP, and like I said, bastions are called jump boxes in Australia. And you cannot use a NAT gateway as a bastion host. Moving on to Direct Connect, just remember what it is. It directly connects your data center to AWS, and it's useful for high throughput workloads, i.e. lots of network traffic, or where you need a stable and reliable and secure connection. Also remember the steps to creating a Direct Connect connection. Go ahead and watch that YouTube video that I linked in that lecture. Like I said, I don't have a Direct Connect connection, so I can't actually show you myself, but Amazon have kindly released one on YouTube. So the first thing you do is you create a virtual interface in the Direct Connect console. This is known as a public virtual interface. You then go to the VPC console and then to VPN connections, and you create a customer gateway. You then create a virtual private gateway, and you attach the virtual private gateway to the desired VPC, very much like how you would attach an internet gateway. You then go to VPN connections and create a new VPN connection, and then select the virtual private gateway and the customer gateway. And then once the VPN is available, you need to set up the VPN on the customer gateway or firewall. Moving on to Global Accelerator. Basically, for the exam, all you need to know is what it is and where you would use it. Essentially, it's a service where you create accelerators, and these improve availability and performance of your application for local and global users. And what's happening is your user is going to the AWS Edge network, and then it's traversing AWS's own internal backbone network to get to your EC2 or to your application load balancers or to your different endpoints, etc. So you get a lot more reliability. When you create a global accelerator, you're assigned to static IP addresses. You can also bring your own, and you control traffic using traffic dials, and this is done within the endpoint group. And an endpoint group will then point to different endpoints, and an endpoint is just things like an application load balancer, a network load balancer, it could be an EC2 instance or an elastic IP address as well. And you can also control weighting to the individual endpoints using weights. And then finally, we move on to VPC endpoints. And VPC endpoints enable you to privately connect your VPC to supported AWS services and VPC endpoint services powered by Private Link without requiring an internet gateway, NAT device, VPN connection, or AWS Direct Connect connection. And instances in your VPC do not require public IP addresses to communicate with resources in the service. Traffic between your VPC and the other services does not leave the Amazon network. So this is what it looks like. We've got our instance. It then connects to our VPC gateway, which then connects on to our AWS services. So this could be S3 or DynamoDB. And there's two types of VPC endpoints. So we've got our interface endpoints, and that has a whole bunch of different services that you can connect into. But then we've got our gateway endpoints, and our gateway endpoints are only support two services, S3 and DynamoDB. So moving on to AWS Private Link, we had a network diagram in here. Just remember, if you see a question asking about peering VPCs to tens, hundreds, or even thousands of customer VPCs, I want you to think of Private Link. It doesn't require VPC peering, and there's no route tables, NAT gateways, internet gateways, etc. All it does is it requires a network load balancer on the service VPC, so you can see it in here, and then an ENI on the customer VPC. So if you see anything about peering to multiple VPCs and you want the most efficient way possible, think of AWS Private Link. Moving on to Transit Gateway. Transit Gateway is a great way of basically simplifying your network topology within AWS. It works on a hub and spoke model. You can connect your different VPCs via Transit Gateway, VPN connections, Direct Connect, etc., etc. So it allows you to have transitive peering between thousands of VPCs and on-premise data centers. Like I said, it works on a hub and spoke model. It works on a regional basis, but you can have it across multiple regions, and then you can use it across multiple AWS accounts using RAM or Resource Access Manager, and you can use route tables to limit how the VPCs talk to each other, and it also works with Direct Connect as well as VPN connections. And of course, it supports IP multicast, which is not supported by any other AWS service at this time. So if you see a question talking about basically simplifying your network topology, being able to support multicast, working on a hub and spoke model, I want you to think of Transit Gateway. We then had AWS VPN Cloud Hub. This is again a way of just simplifying your VPN connections. So you basically put in VPN Cloud Hub here, and essentially it will allow your customers in New York to talk from site to site. So we'll be able to talk from New York to your VPC over a VPN connection, but then they'll also be able to speak to the network in Miami over another VPN connection. It's basically a way of concentrating or making a hub out of your VPNs. So if you have multiple sites, each with its own VPN connection, you can use AWS VPN Cloud Hub to connect those sites together. Like I said, it's a hub and spoke model. It's low cost, it's really easy to manage, and it operates over the public internet, but all traffic between the customer gateway and the VPN Cloud Hub is going to be encrypted. And then very last one was just about network costs and how networking works. So we just saw that in the last lecture. Use private IP addresses over public IP addresses to save on costs when you're doing communication within your VPC. This is then going to utilize the AWS backbone network. If you want to cut all your network costs, go ahead and group your EC2 instances in the same availability zone and use private IP addresses. This is going to be cost-free, but make sure that you bear in mind single points of failure issues. So you've done really well. This is the most complicated part of the entire course. Going into the exam, I would 100% recommend learn how to build a VPC from memory and make sure your instances in a public subnet can communicate to your instances in a private subnet, and your instances in the private subnet have a way of, doing yum updates. If you can build out a VPC from memory and deploy instances in public and private subnets, again from memory, you are going to smash the exam. You're basically going to get all the networking components right, and the networking components make up a huge part of the exam. So I highly recommend going into the console, playing around, build your own VPC from memory, and make sure that you know how to get your EC2 instances in private subnets able to do yum updates, and then you absolutely kill the networking components of the exam. So congratulations, you're at the end of this section of the course. It, like I said, is the most complicated. I hope you had lots of fun, and if you got the time, please join me in the next section. Thank you.